Introduction. Most of the substances around us undergo changes. Some of these changes can be temporary, with no new substances being formed. They are called physical changes. In certain other changes, new substances are formed and the parent substance loses its identity. In such changes, we cannot get back the original substance from the new substance by simple means. They are called permanent changes. For example, burning of paper to yield carbon. When paper is burnt, black particles of carbon ash is formed. Now it is not possible to get back paper from it. This is a permanent chemical change. Objectives. At the end of this lesson, you'll be able to recognize chemical changes, write equations to represent a chemical reaction, classify chemical reactions, list examples for different types of chemical reactions. Chemical reactions. A chemical reaction is that in which a substance or substances react chemically to form a new substance or substances. The substances that take part in a chemical reaction are called reactants. The new substances which are formed are called the products. Iron plus sulfur gives iron sulfide. Iron and sulfur are the reactants and iron sulfide is the product. When sugar is heated, it gets charred. The water molecules in the sugar leaves behind carbon. Writing a chemical equation. In a chemical reaction, the reactants, one or more, react together and form a new compound known as the product. For example, aluminium oxide reacts with dilute sulfuric acid to form aluminium sulfate and water. The reaction can be written as aluminium oxide plus dilute sulfuric acid gives aluminium sulfate and water. Writing a chemical equation. The following steps are followed to write a chemical equation. Symbols and formulae of reactants are written first on the left-hand side. If there is more than one reactant, then a plus sign is placed between the different reactants. Aluminium oxide and dilute sulfuric acid, for instance, are written as Al2O3 plus H2SO4. An arrow is marked after the reactants to indicate that they react to form the product. Symbols and formulae of the compounds formed, products, are written after the arrow on the right-hand side, which indicates that these are formed. Here also a plus sign is placed between the different compounds formed. For example, Al2O3 plus 3H2SO4 gives Al2SO4 3 plus 3H2O. Balancing the equation. The chemical equations are based on the law of conservation of mass. According to this law, mass can neither be created nor be destroyed in a chemical reaction. This will be possible only if the total number of each type of atom is the same on the reactant side as well as on the product side of the equation. Equations in which the number of atoms of different elements in the reactants are the same as the number of atoms on the product side are known as balanced equations. Balancing the equation. Al2O3 plus H2SO4 gives Al2SO4 3 plus H2O, equation 1, the above equation is an unbalanced one. There is only one atom of sulfur in the reactant side, while there is 3 atoms of sulfur in the product side. Al2O3 plus 3H2SO4 gives Al2SO4 3 plus H2O, equation 2. Now there are 6 hydrogen atoms on the reactant side and only 2 hydrogen atoms in product side. Multiply H2O molecules in the above equation by 3. Now the equation 2 becomes Al2O3 plus 3H2SO4 gives Al2SO4 3 plus 3H2O, which is equation 3. Now in the equation 3, the oxygen atoms are 15 both in reactant and product side. So the final balanced equation is Al2O3 plus 3H2SO4 gives Al2SO4 3 plus 3H2O. Different types of chemical reactions. Elements and compounds interact with each other to produce a variety of substances. Millions of compounds have been formed by chemical reactions between elements or compounds. Chemical reactions require different sets of conditions such as temperature, pressure, presence of light, etc. Chemical reactions occur in a variety of systems. For example, in the human body, plants, industries, nature, etc. Types of chemical reactions. Combination reaction, decomposition reaction, displacement reactions, double displacement reactions. Combination reactions. In some reactions, new matter is added to the original substance and the substance gains in mass. Such a reaction is called a combination or synthesis reaction. Combination reactions are those in which one element reacts with another to form a compound. Such reactions are also known as synthesis reactions. For example, hydrogen combines with oxygen to give water. 2H2 plus O2 gives 2H2O. 2Cu plus O2 gives 2CuO. 4Fe plus 3O2 gives 2Fe2O3. Rust. Take a magnesium ribbon and heat it over a flame. It burns, giving out a bright white light. The magnesium ribbon becomes white powder. Now add some water to the powder and put a drop of red litmus. The red litmus turns blue. This is due to combination reaction. Oxygen in the air combines with magnesium to give white powder of magnesium oxide. Magnesium oxide reacts with water to give magnesium hydroxide. Being basic, it turns red litmus blue. Decomposition reactions. Decomposition reactions are those in which a compound breaks down into simpler compounds. For example, on heating, calcium carbonate decomposes to give calcium oxide and carbon dioxide. CaCO3 gives CaO plus CO2. Water decomposes to give hydrogen and oxygen when electricity is passed through it. Take a piece of a marble. Hold it with a pair of tongs. Heat it over flame for some time. Now let it cool. Drop the solid into water. Add a drop of red litmus to the solution. The color of litmus changes to blue. Calcium carbonate marble decomposes to calcium oxide and carbon dioxide. The calcium oxide formed reacts with water to give an alkaline solution. Therefore, red litmus turns blue. Take 0.5 gram of zinc carbonate in a test tube. Fit the test tube with a cork and a delivery tube. Heat over the flame. You will see a colorless gas is given out. The gas, on passing through lime water, turns it milky. Heating zinc carbonate decomposes it to carbon dioxide gas and zinc oxide. The carbon dioxide turns lime water milky. Heat about 1.0 gram of ferrous sulfate in a china dish. On strong heating, the green color of ferrous sulfate changes to brown. A pungent-smelling gas also comes out of it. This is due to the decomposition of ferrous sulfate to give brown ferric oxide and pungent gases like SO2 and SO3. Displacement reactions. A displacement reaction is a reaction in which an atom or a group of atoms present in a molecule is displaced by another atom. For example, iron when added to a solution of copper sulfate displaces copper metal. Dissolve 0.5 gram of silver nitrate in 10 ml water in a test tube. Place a clean copper wire in the test tube. Keep it for some time. Shining crystals of silver appear on the copper wire. The color of the solution becomes bluish as some copper nitrate is formed. In this reaction, iron metal has displaced copper from the solution of copper sulfate. Take copper sulfate solution in a test tube. Place the iron nail in the copper sulfate solution and keep it for some time. After some time, the blue color of the solution fades and red-colored copper metal is displaced from the copper sulfate solution. The displacement reaction which occurs is Fe plus CuSO4 gives FeSO4 plus Cu. Some other examples of displacement reactions are 2Na plus 2H2O gives 2NaOH plus H2. 2Al plus Fe2O3 gives Al2O3 plus 2Fe. Double displacement reactions. Double displacement reactions are those in which two compounds exchange ions to form two new compounds. These reactions are also called partner exchange reactions. These reactions occur in ionic compounds. For example, in the reaction of copper sulfate and hydrogen sulfide, copper sulfite and sulfuric acid are formed. Thus, the partner of copper is exchanged for the partner of hydrogen in hydrogen sulfide. The reaction of barium chloride and sulfuric acid to form barium sulfate is also a double composition reaction. The neutralization reactions are also double decomposition reactions. Redox reaction. Redox reactions are those in which oxidation and reduction takes place at the same time. In these reactions, one substance is reduced while the other is oxidized. Activity. Take a china dish and add a small amount of copper powder and heat it. What happens to copper powder? The surface of copper powder has changed to black color. This is because oxygen has combined with copper and copper oxide is formed. If hydrogen gas is passed over this heated material, CuO, the black coating on the surface turns brown as the reverse takes place and again copper is obtained. Cupric oxide changes into copper. Oxygen is thus removed from cupric oxide. Since removal of oxygen is reduction, cupric oxide is reduced to copper. Hydrogen removes this oxygen from cupric oxide. Hence, hydrogen is the reducing agent. Thus, oxidation and reduction occur simultaneously. For example, sodium gets oxidized when it changes to Na+. Oxidation is defined as the gain of oxygen or loss of hydrogen or loss of electrons by a substance. Reduction is defined as the gain of hydrogen or loss of oxygen or gain of electrons by a substance. Zinc gets oxidized to Zn2+ when a zinc rod is dipped in a copper sulfate solution. In this reaction, zinc has lost 2 electrons to become Zn2+. Thus, zinc gets oxidized. On the other hand, Cu2+ gets reduced as it accepts 2 electrons released by Zn to become Cu. Corrosion. You might have noticed that old iron gates turn reddish-brown in color. The turning of iron materials into reddish-brown color is rusting of iron. Some other materials also tarnish the same way. The black coating on silver and the green coating on copper are other examples of corrosion. Corrosion is the process by which metals are eaten up gradually by the action of air, moisture, or a chemical on their surface. Rancidity. If a metal is reactive, its surface may be attacked slowly by the action of oxygen and water in the atmosphere. The metal reacts with the oxygen of air and water vapor of air, forming compounds on its surface. The formation of these compounds tarnishes the metal. That is, it makes the surface of the metal appear dull. The compounds formed on the surface of metal are usually porous and gradually fall off from the surface of metal, and then the metal underneath is attacked by air and water. The process goes on and on. In this way, the action of air and water gradually eats up the whole metal. When we keep food materials containing fat or oil for a long time, we get an unpleasant smell and the taste also changes. This is because the food materials get rancid. Rancidification is the decomposition of fats and oils by hydrolysis or by oxidation. Antioxidants are often added to fat-containing foods in order to retard the development of rancidity due to oxidation. Natural antioxidants include polyphenols, ascorbic acid, tocopherols. Synthetic antioxidants are butylated hydroxyanisole and butylated hydroxytoluene. Rancidification can be prevented to some extent by keeping food in refrigerators, by storing food away from sunlight and in airtight containers, by filling the nitrogen in packaging food materials. The nitrogen gas prevents the food material from being oxidized and thus prevent rancid. Did you know? A solution of slaked lime produced by the reaction is used for whitewashing walls. Calcium hydroxide reacts slowly with the carbon dioxide in air to form a thin layer of calcium carbonate on the walls. Calcium carbonate is formed after 2 to 3 days of whitewashing and gives a shiny finish to the walls. It is interesting to note that the chemical formula for marble is also CaCO3. Summary. Let us summarize what we have learned. Chemical reactions are permanent changes. Each chemical reaction can be represented by a balanced chemical equation. The different types of chemical reactions discussed are combination reactions, decomposition reactions, displacement reactions, double displacement reactions, redox reactions.